Theoretical versus experimental probability. Chapter 3, Section 3. Theoretical probability shows what should happen in an experiment. Experimental probability shows what actually happens in an experiment. Now let's think about this for a second. Theoretical probability. It's like a theory. It's what should happen. If you flip a coin 2 times, then you would theoretically get a head once and get a tails once. Okay? But when you do an actual experiment, which is experimental probability, if you flip the coin twice, you could very well get 2 heads, 2 tails, or even a head and a tail. So that's basically the difference between theoretical and experimental probability. Jim tossed a coin 35 times. He recorded whether the coin showed head or tails. Use the results in the table to find each experimental probability. So we're talking about experimental probability, and here are the results of the experimental probability. He marked down each time he got a head and each time he got a tail. So we're looking for the experimental probability of getting a head. Well, first of all, I have to find the total amount of flips. Looks like there was 5, 10, 15, 20, 25, 30, 35 total flips, and so that's going to be my bottom number. So out of the 35 flips, he had 5, 10, 15, 20 heads, which reduces to 4 out of 7. Number 2, the probability of getting tails. Looks like there were 15 tails out of 35 flips, which reduces to 3 out of 7. Number 3, what is the theoretical probability of throwing heads? Now, remember, theoretical is what should happen, so the theoretical probability should be 1/2, or 0.5 if you wanted to give me the decimal, or 50% if you want to give me the percent. Now remember what we've been talking about, and I know it's been kind of what I've been expecting from you as far as what type of answer. I've been kind of loose with that, with this probability. I want you to think about it. If you're dealing with dice or coins or things like that that people normally wouldn't deal with, then you can leave it as a fraction. It's okay. If you're doing experimental probability with dice, or even theoretical probability with dice or coins, leave it as a fraction. But if you're dealing with a real life situation, such as from lesson 1, we were talking about body weight of different males and females, and if you end up with a very large fraction, like say 344 over 5,000, that doesn't make a lot of sense. It's not very relevant to you. So you want to go ahead and use the percentage at that time. Number 4, what's the theoretical probability of getting a tail? Well, that's the same. It's 1/2, or 0.5, or 50%. Number 5, what is the difference between the experimental probability of throwing heads and the theoretical probability of throwing heads? And we want to write our answers as a percent and round to the nearest whole percent. Now this is where you have explicit directions to give a percentage as an answer. Now I'm looking at 2 different things. I'm looking at the difference between the experimental probability and the theoretical probability. So experimental probability comes first. The experimental probability of throwing a head was 4 out of 7. I'm going to go ahead and use the reduced form. And difference meaning subtract, so the difference between experimental probability and the theoretical probability of throwing heads. Well, the theoretical probability was 1/2. So the difference between these two is, well, you have to subtract these 2 fractions. And before you can subtract fractions, I hope you remember that you must have a common denominator before you can subtract. Between 7 and 2, our common denominator is going to be 14. 7 goes into 14 2 times. 2 times 4 is 8. 2 goes into 14 7 times. 7 times 1 is 7, which leaves you with 1 over 14 is the difference. Now we want the decimal percentage, or the not the decimal percentage, but the actual percentage. So when you use your calculator and you divide 1 by 14 and move the decimal place 2 places to the right, you get 7%. Again, you divide 1 by 14, move the decimal place 2 places to the right, and you round it to the nearest whole percent, so you get 7%. The difference in throwing tails. Well, the experimental probability of throwing a tail was 3 out of 7. The theoretical was still 1/2. So again, my common denominator is going to be 14. I don't know if you've ever seen a fraction being subtracted like this, but notice that my denominators, when I'm adding or subtracting, don't change. So I'm just going to make one denominator. And 7 goes into 14 2 times. 2 times 3 is 6. 2 goes into 14 7 times. 7 times 1 is minus 7. And I get that that is a negative 1 over 14, which there's not going to be a negative percentage. What that negative sign is telling me is that the difference is 7% below. So if my negative sign told me that it was 7% below, then up here for my heads, since it was positive, that told me that it was above 7%. James spun a spinner 30 times. The following is recorded of his results. So all of these little marks here are the results from when James spun the spinner. Okay, James spun it 30 times. James probably a little bored, doesn't have anybody calling him on his cell phone or texting or anything like that. So here we go. Find each experimental probability. The probability of being yellow. Well, if he spun it 30 times, then 30 is going to be on bottom, and there are 1, 2, 3, 4, 5, 6 yellows, which reduces to 1 out of 5. Number 8, probability of being purple. Again, 30 is going to be on the bottom, and there are 1, 2, 3, 4, 5, 6, 7, 8, which reduces to 4 over 15. Number 9, the probability of being blue. 4 out of 30, which reduces to 2 out of 15. Number 10, probability of being green. 5 out of 30, which is reducing to 1 over 6. Number 11, probability of being red. 7 out of 30, which does not reduce. Number 12, the probability of being green or blue. Green or blue, so we have 5 greens and 4 blues, so we have 9 possible ways of being green or blue. So that would be 9 out of 30, which reduces to 3 out of 10, using the common factor of 3. Number 13, yellow or purple. Well, there are 6 yellows and 8 purples. That gives a total of 14. So that would be 14 out of 30, which reduces to 7 out of 15. Number 14, the probability of being red or blue. Well, there is 7 reds and 4 blues, which gives a total of 11. So I have 11 out of 30, which does not reduce. What are the theoretical probabilities of the following outcomes? Now we're talking about still this spinning this spinner here. It has 1, 2, 3, 4, 5 possible outcomes. It could have been yellow, purple, blue, green, or red. So the probability of getting a yellow would be 1 out of 5. Of getting a purple, again, 1 out of 5. Getting a blue, 1 out of 5. Because theoretically, if you spin it around, what you would expect to get is at least hit that color once, and so it will be 1 out of 5. Probability of getting a green, 1 out of 5. Number 19, 1 out of 5 getting a red. Number 20, a green or a blue. Well, there's 2 possible chances there, so that would be 2 out of 5. Yellow or purple, again, 2 out of 5. Number 22, probability of red or blue, again, 2 out of 5. What is the difference between the experimental probability and the theoretical probability of each of the following? So we want to subtract the theoretical from the experimental. Write your answers as a percent rounded to the nearest whole percent. So spinning a yellow. The experimental probability of spinning a yellow was 1/5. And I want to subtract the experimental or the theoretical probability, which was also 1/5. So the difference between the two, the experimental and the theoretical probability in this case, was 0%. Spinning a red. The experimental probability of spinning red was 7 out of 30. And the the theoretical probability of spinning a red was 1 out of 5. So I need to subtract this. And I know that you can use your calculators because we're going to be getting this percentage here. But I'll just do a quick example of how to do it as a fraction first. Common denominator is going to be 30. The 7 stays the same. 5 goes into 30 6 times. 6 times 1 is 6. 7 minus 1 is 1, so 1 over 30, which gives me the percentage of approximately 0.233%. I'm sorry, 0.033%. 0.033%. And since it was positive, then it's 0.033% above. So what that means is that we had more reds during the experiment when James was actually spinning the spinner than what you would expect to happen theoretically. Let me make a quick correction real quick. It was 0.033, but when I make the percent, it's going to be 3% rounded to the nearest whole because it would be 3.3%. So since I'm rounding it to the nearest whole percent, it'd be 3% above. Sorry about that. I wrote down the decimal equivalent. So 3% above. Number 25, spinning a red or a blue. On the other side, during the notes, we found for number 14 the experimental probability for rolling or spinning a red or a blue, and that was 11 over 30. So I need to subtract the theoretical probability of spinning a red or a blue, which we also found that one on number 22, which was 2 over 5. So I need to go ahead and subtract these. My common denominator is going to be 30. The 11 stays the same. 5 goes into 30. 6 times 2 is 12. That gives me negative 1 over 30. And if 1 over 30 was 3%, the negative 1 over 30 is going to be 3%. But since it's negative, it's going to be 3% below. So again, in a recap, the difference between theoretical probability and experimental probability is theoretical is what you would expect to get. Experimental probability is what you actually get when you do an experiment.